Welcome to The Explainer. Today we are diving into a really fascinating paradox that sits right at the heart of computer science. And it's a concept that kind of seems to defy all common sense.
I mean, it sounds completely backwards, doesn't it? It's like trying to organize a messy room by first throwing everything on the floor. But, as we're about to see, this incredibly counterintuitive idea is the key to some of the most powerful data compression in the world.
So, to really get the solution, we first have to understand the problem. Why is it that some files can be shrunk down to almost nothing, while other files, they barely budge?
Okay, think of it like this. Compression algorithms are basically professional pattern finders. They're looking for repetition, like the word the appearing over and over again, and they replace it with a tiny little shortcut. But when data looks totally random and chaotic, well, there just aren't any simple patterns to find. The algorithm is completely stumped.
So what if, instead of trying to compress this mess directly, we first organized it in a much cleverer way? This is where a truly ingenious algorithm comes into play.
Let's break this down a bit. The Burrows Wheeler Transform, or BWT for short, is the star of our show today. Now, the key word you really got to focus on is transformation, not compression. It doesn't actually shrink the data itself. Instead, it ingeniously shuffles the data's deck of cards in a very specific way. You can think of BWT as a brilliant setup artist. It takes that messy, random-looking data and it reorganizes it, creating order where there was none before. It then hands this newly structured data over to a standard compression algorithm, which can now work its magic way more effectively.
So how does this reordering actually work? How does it manage to create patterns out of what looks like total chaos?
Let's use an analogy. Imagine your data is a really messy bookshelf. You got books of all different colors and sizes just shoved in there randomly. If you had to describe this shelf to someone over the phone, you'd have to list every single book one by one. It's a super long, inefficient description. That's our original data.
Now, after BWT does its thing, it's like sorting your bookshelf by color. You haven't gotten rid of any books, but now your description is so much simpler. I've got 5 red books, then 3 blue ones, then 7 green ones. By clustering similar items together, you've created repetition that's super easy to describe. That is exactly what BWT does for data. And here's the most amazing part. You might think that scrambling data this way would be destructive, right? That something would get lost, but it's not. BWT is a perfectly lossless process. You can always reconstruct the original, perfectly ordered bookshelf from the color-sorted version without losing a single page. This clever idea isn't just some fun thought experiment. It's a real workhorse out there in some of the most demanding fields of technology and science today.
If you've ever used a file compression tool like BZ2, you have used the Burrows Wheeler Transform. But its biggest impact, you could argue, is in bioinformatics, where scientists need to analyze these enormous genetic databases.
And we are talking about genetic sequences containing billions of base pairs. Trying to find patterns in that massive amount of data would be nearly impossible without a smart pre-processing step. BWT clusters similar genetic markers together first, making the entire analysis fast and incredibly memory efficient.
So, after all this, what's the central lesson? What should we take away from the elegant genius of the Burrows Wheeler Transform?
The takeaway is really this beautiful idea. The most effective solution wasn't a more powerful compression algorithm. It was a clever change in perspective. It was about preparing the data, transforming chaos into order before even trying to solve the compression problem.
And that leaves us with a final thought. This principle doesn't just apply to data. Where else in our work, our lives, or even in our biggest global challenges could we find a breakthrough, not by pushing harder, but by simply rearranging the pieces first?